is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goyal Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject microcontroller for and embedded systems design having code KEC 061, what we have completed? We have completed unit number 1, 2, 3 and 4, and in the few lectures back we have started with the unit number 5. Unit number is 5 is basically a development of the IoT applications through CMSIS or through embed tools. So, in the 2 lectures back we have started with the embed platform. Okay. So, we have left with the few things of embed platform. So, in this lecture we will discuss the embed SDK and SDK. In the previous lecture we have discussed the functionalities of embed, you can check that, and components of available in the embed, how the embed license agreement is done, what are the tools available, we have seen in the previous lecture. So, in this lecture we will talk about the embed SDK and SDK. Under this, these are the table of contents. We will just a second, I am taking the marker. So, these are the table of content that we will discuss in this lecture. Under first topic, that is identify the features offered by the embed SDK and SDK. We will learn the embed software development kit. We will learn the features of embed SDK. We will learn the embed hardware development kit available and benefits of the SDK. Okay. After that, we will learn about the embed OS connectivity and applications of embed. So, basically let us start with the first topic, that is features of the embed SDK and SDK. So, what is the meaning of SDK? SDK means software development kit. S means software, okay. D means development and K means kit. We are talking about the development kit. In the previous lecture we have discussed that the code which is right in the embed is compatible with every hardware development kit. So, we are talking about the that hardware development kit. So, SDK means hardware development kit, okay. All are available in embed. These are the components of actually embed system. So, first we will talk about the embed SDK, that is embed software development kit. Embed software development kit, it includes software libraries, it has all the libraries available, it has all the codes available to run any particular IoT applications. Okay. It has a C, C++ software libraries, it has a large number of libraries available, we can easily access it. It has a startup code. Startup code means that for example, each programming language, whether in the embedded programming, it is assembler programming or C++, there are some lines common. For example, we have in the previous lecture we have studied some programming like watchdog timer programming. So, there are some lines common. For example, in the we need to stop the watchdog timer before the program so that it cannot reset the system. So, there are some common lines available. So, it has some startup codes are available, it has some peripheral drivers are available, it has a networking unit, okay. It has a real time operating system, we work on the only on the real time operating system. It has a runtime environment, it has IDE, integrated development environment, under which all the things are available. So, it has a community development libraries and codes are also available there. We can has a large number of libraries, large numbers codes are available, easily can be accessed by the everyone very easily. Okay. So, it has a cookbook of hundreds of reusable peripherals, it has input output units are available, and module libraries have been built on top of the SDK, which can be used to build your projects faster. So, you can before going into the project, you can run it feasibility, you can check its feasibility through the in the internet, through the embed platform. Okay. It has a large number of software tools are available such as build tools, test and debug scripts are. So, you can create the code, you can debug the code, you can run the code, okay. You can burn that code into the ARM microcontrollers, all are available in the embed, okay, under SDK components. So, here some other features are like under embed software development kits, there are some other features like licensed under the permissive Apache 2.0 license. In the previous lecture, we have all seen, we have seen that Mbed platform has some licensing agreement, but is freely available. Okay, so it has a licensing agreement available under the Apache 2.0 license. Okay, all can be used in both commercial and personal projects with confidence. So it is not like that if this is a freely version, only limited tools are available. All the tools are freely available, anyone can use them. Okay, so any commercial and personal projects, anyone can use that. So it is compatible with different hardware platform. So different hardware platform, it is compatible. The code you have written for particular application can be used in any type of hardware. It is for any microcontrollers like 8051 PIC microcontrollers, ARM microcontrollers. Okay, all are compatible with the Mbed programming, Mbed codes. It support multiple tool chains, they are support. Okay, many tools, many libraries are available there. Okay, so there are many vendors, there are many developers of the Mbed, like ARM Keel, tools by ARM. We have already seen that Keel compilers are there. Okay, GCC, code sorcery, source code oblique red, all are the vendors of the Mbed. Okay. So under this topic, Mbed software development kit, we will see the supported tool chains and ID. So these are the supported tool chains: GCC ARM, ARM CC, IAR, GCC code red, GCC code sorcery. So basically, this is basically a theory. For implementation, you need to go into the Google. You have to check the Mbed platform. After that, you are able to understand the things in a better way. Okay. So GCC ARM basically is a graphical GNU tools. All the tools are available here. Okay, for ARM embedded processor, any application, all the tools are available for any application. Okay, ARM CC standard libraries and micro lab, micro vision available. It has IR embedded workbench. GCC code red suits are available. GCC code sorcery for code bench. So Mbed SDK is open source, and a large number of codes are available to large number of users, and for any application they are compatible. Okay. So features of Mbed SDK, more features. Compatible with different hardware platform. It is compatible with the large number of hardware platform. NXT series microcontroller include. We will see some of the series. ARM Cortex M series of microcontrollers. M means microcontroller. So ARM Cortex microcontrollers, they are compatible. The code which we are writing in the Mbed. So M0, M0 plus, M3, M4. These are the families of the ARM microcontrollers. All are compatible with the source code of the Mbed. Okay. So under Cortex M0, LPC 11U24, LPC 1114, LPC 11C24, LPC 43304, all the development kits are available and they are compatible with the Mbed. M0 plus, LPC 810, LPC 812, LPC C1768, LPC 1347, LPC 4088, LPC 4330, all are compatible with the Mbed. Under ARM 7 TDMI-S, LPC 2368. So there are large number of development boards that is compatible with the Mbed platform. Here you can see Mbed LPC 16768, Mbed LPC 11024, Freescale KL255Z, all are compatible with the Mbed SDK. So it is Freescale series microcontroller including ARM Cortex M0 plus KL series, like here 250Z, 225Z, 05Z, all are compatible with the Mbed. ST microelectronic series microcontroller including Cortex M4 and STM32F407. So the code which are written into the Mbed are compatible with different hardware platforms we have discussed here. ARM Cortex board, many Cortex board, they are compatible. Okay. So in the previous slides we have discussed the Mbed SDK, software development kit. From this slide we will discuss the Mbed hardware development kit, HDK. under this topic, features of the embed SDK and SDK. So, first we will see the what is the function of the hardware development kit. So, the embed hardware development kit SDK provides recipes to build custom hardware devices. It provides the solutions to the customer hardware devices, how the hardware devices can be implement and prepare. It is provides the microcontroller subsystem design files and firmware. So, basically hardware is made up of the microcontrollers. It is a key component. It has a input and output peripherals units are available. So, so in the same way, any development board, any embedded hardware development board should have microcontrollers, should have some processors, so that we can design files and firmware. Okay, it has a specifications of all support components and circuit. So, it has all support units available, all circuits available, all supporting components available, which can help the user at any time. Okay. It has a embed hardware platform off the shelf development boards such as Freedom KL245Z, NXC LPC1768 board, Bluetooth LE enabled Nordic and RF51822 board. So, there are large number of boards available which can help any type of application. Okay. So, this is the embed hardware development kit. In this hardware development kit, you can check, this is the evaluation board. Okay. This is the evaluation board. This is basically a development board like this. So, before going into this, you can check, I am taking the example of Arduino. If you can check the Arduino board, you can check it has USB modem, it has a reset system, it has its watchdog timer, it has a timers, it has a microcontrollers, it has a oscillator circuitry, all the components are there in the Arduino board. In the same way, if you have checked into the embed hardware development kit, there are a lot of functions available. It has its evaluation board. Under evaluation board, it has a reset button, it has a USB port, so that outside they can communicate, they are communicate outside with the world. It has a target power board, it has a onboard interface unit. So, all are communicating through the target microcontroller. So, target microcontroller, what is the meaning of target? Means that if you are writing codes into the embed platform, this code can be targeted, can be burned into the microcontroller. Microcontroller may be anything, but we are but the development board is provided by the ARM Cortex. Microcontroller may be anything. Okay. So, it has a peripheral unit, large number of peripherals. Peripherals means that it has a ADC unit also, it has a analog to digital converter, it has a digital to analog converters are there. Okay. It has a input output unit, it has a output unit. Okay. It has a oscillatory unit, it has a power unit. So, all the things are available in our IoT, in our embed hardware development kit. So, this is the hardware development kit. So, an example of how a microcontroller subsystem might be used to build an evaluation board. So, this is the embed hardware development kit. So, what should be the benefits of the hardware development kit? So, hardware development kit very easy to design. It has a quick design shortcut using ready-made schematics. So, what is the meaning of is that ready-made schematics? All the it has a large number of circuits which are already ready-madely available. What is the meaning of ready-made? Means that already fabricated, already integrated in the embed. If you have any problem to designing, you can go into the help section of the embed. You can check the large number of boards are available, large number of schematics are available, you can use that. So, it is quick design shortcut, means that quickly you can design and develop any hardware by using the embed. So, it provide easy to use USB. The USB is available, very easy to use, anyone can use it. Okay. Universal serial board. So, in the previous slide we can see that in any hardware development board, there are USB available, reset available, and we have a microcontrollers, we have a large number of peripherals, all are available in embed. So, it has a the USB port available in the embed is very easy to use, anyone can use it, and debugging support. It has a debugging support. Debugging means that if any error occur in the your programming, it can be easily debugged in embed application. Okay, very easy to use. It is compatible with embed SDK. Embed it means that embed SDK means embed software development kit. So compatible with embed SDK means that the any hardware development board which we are using for any particular application, it is compatible with the embed SDK. Anyone can use it, very easy way. It is easily available to the user. Anyone can use it. So features of the embed SDK and SDK, we will discuss about the embed OS connectivity. So because we have written the program, we have run the program into the microcontroller, but when we are transmitting the data collected by the hardware devices, we need IoT connectivity. We need connectivity. We have to transmit data to a long distance, to a short distance as well. Okay. So for that we have a broad large number of devices available. They are responsible to transmit data to a large distance or short distance. That may be depends, range vary upon the particular IoT connectivity wireless protocols. Okay. So a broad range of connectivity options are available in embed operating system supported with software libraries, development hardware, tutorials and examples. It has all. So it has a Bluetooth low energy. We have seen that Bluetooth is a very short range, up to 10 meters you can use it. Its transmission range is less, data rate is we have seen that. So Bluetooth is used for short range only, you can transmit data. It has a near field communication, NFC means near field communication. It has a active and passive unit. You can, it has a very short range, only in the within a few centimeters you can transmit the data from the one NFC device to the another device. For example, two mobile devices, one mobile device is capable to communicate with another device within short range. For example, NFC example is your credit card, smart card, plastic cards. So you can use then cards in a very close proximity. It based upon the close proximity principle. We have a RFID as well, radio frequency identifications unit as well. What is the responsibility of the this RFID radio frequency? It is also a short range. It has same principle like NFC. Okay, very short range. Its range may be larger than the NFC, but it itself has a short range as compared to another devices. It works on the RF module. Okay, it has a, we have a Wi-Fi unit. Nowadays we are using a Wi-Fi in a large number of large aspect. Wi-Fi means wireless fidelity. For that we need to install the Wi-Fi routers, Wi-Fi gateways, etc. So Wi-Fi means it has a not a large range. It's a very few range, 100 meters. We can easily access the data through the Wi-Fi devices. After that we have Ethernet. Ethernet range is not much large. To connect several computers in an organization, we need Ethernet devices. This is basically a hardware devices as well, physical devices. Hardware means like cable devices, not cableless devices. Okay. We have a cellular technologies, like 2G, 3G, 4G, 5G. They provide internet connection through which we can transmit the data. And we have a LoRa LPWAN, long range, low power, wireless area network, wide area network. Sorry. So we have seen this is the symbol of the LoRa, and we have seen that it has a large range. As the name implies that LoRaWAN is used to transmit the data to a large range. A range may vary up to 100 of kilometers, but all these devices have very short range. We can transmit only data to a very short range, but these two devices can transmit data to a very large range. They ensure and it also it has a LP means that low power devices. Its power consumption is very less. It is energy efficient, energy consumption is very less, and it is easy to deploy. Okay. After that we have a 6 LoWPAN sub gigahertz mesh network. 6 means IPv6, we have seen in the previous lectures, and it has a IPv6 low wide personal area network. Sub gigahertz, it has a gigahertz range, and it works on the mesh technologies. mesh. This is the mesh architecture, like this one, this is the mesh architecture. All are interconnected with each other. Mesh means that if we are communicating from this device to another device, if this node is failed, then the transmit data can be transmitted from through this way or from this way, okay. So this follows the mesh architecture as compared to star architecture. Star has some deficiencies, we cannot transmit data to a long range, it has some node connectivity issues, okay. So these are the embed OS connectivity available, features of the embed SDK and SDK. So after that we have a device and component support, okay. Embed provide the device and component support, which device you have to use, which component you have to use, all are the things are integrated into the embed. Embed provides access to the user, okay. So with support for embed operating system on a wide range of ARM Cortex M based devices, developers can prototype IoT applications quickly on low cost development board. So what is that? Any prototype can be developed for any IoT applications. You can develop any prototype, rapid prototype, and you can use that prototype to any development boards. So the hardware development boards we are talking about are very low cost devices. It has a simple USB drag, USB port is available, USB device, USB feature is available, which can easily can be used. It is easily drag and drop programming allows you to rapidly prototype. So you can easily use that USB application without the need of expensive debug hardware. So you do not need to use external debug hardware devices. It has own debug unit, by you can debug your program, okay. It has a real time software execution. This is the main feature, because all the things are working on the real time. For that you need real time software execution as well, not a general purpose. So with an RTOS core based on the widely used open source CMSIS RTOS RTX embed OS supports deterministic. It has a multi-thread real time software execution as well, okay. So the RTOS primitives are always available, allowing drivers and applications to rely on features such as threads, semaphores and mutexes. So threads, semaphores, mutexes we have seen in the previous lectures, all are things which is used to carry out the operating system operations. How the memory can be effectively utilized, how the shared resources shared among threads, all are possible through the threads, semaphores and mutex. In the previous lecture we have seen that threads are basically the task microcontroller is going to do. Mutexes is used to managing the threads if there are more than one thread in the system, and semaphores is used to manage the resource resource allocation to the threads. They are not managing the threads, they are managing the resource allocation to the threads, semaphores, okay. So all are basically linked with the real time operating system. For example, your car real time is your car, if braking system, if your braking system is not real time, then there will be casualties. If you are applying the brake, your vehicle immediately stop, okay. So this is the real time. Open source available, we have seen that it has embed is available as a open source under Apache 2.0 license. So you can use embed operating system in commercial and personal projects with confidence. Everyone can use it very easy. It is very easy to use. You can use your embed very easily, okay. It is very easy to use, okay, not very typical. So all the libraries codes are available, can be very easily used by the programmer. So with the modulator library structure, the necessary underlying support for your application will be automatically included on your device. Very easy to use, and by using the embed operating system API, application programming interface, your application code can remain clean. The application code we can save it for a further use. It is very clean, portable. Portable means that from anywhere you can access your file that is saved into the embed platform, okay. It is available to the user. portable and simple while taking advantage of security and communication. Security is available, no one can hack it, and communication is available. We provide a huge range of code examples that you can import into your own projects, demonstrating how to use each of the API. So, the open source available, ease of use, community, one code is shared among many users. They are collaborative community. Okay, so the embed community allows contribution and collaboration between ARM. Hundreds of partners and thousands of developers can use all over the world. End-to-end security, the data which are saved into the embed is secure, and device, hardware, software communication in the life cycle of the device. So end-to-end security is option available in the embed. Hardware for security, the combination of PSA. So basically this says that hardware security is available, software security available, codes are secure, communication security, here SSL or TLS are used, that is the transport layer security. Security services are available in the embed. The standard protocols for securing communication on the internet allows you to include them in your ambient project with a simple APIs. Security features are also available. So, last topic we will discuss the applications of embed. There are a large number of applications of embed. You can design anything. So, it has a large number of all drivers are available, support libraries are available. You can use for a wide range of standard microcontroller peripherals. You can create a code, you can debug the code, and can run on any hardware platforms. So, it has a large number of applications, digital analog input, interrupts, port and bus, PWM, I2C, SPI, serial, all can be used by a embed. So, it has a C libraries available, large number of tool chains are available under embed operating system, including implementation of the threads of this Swift. So, large number of applications are there. So, application embed can be developed by using the online ID. Okay. So, it has its own compiler, collaborator, large number of tools. It is compatible with the C++ compiler. So, large number of ports are available, you can use in your system. So, the embed ID provides private workspaces with ability to import, export and share code with everyone. Can export the library, any can import the libraries. So, application can be developed with other development environments such as Keel, Microvision, these are compatible, IR embedded workbench, they are compatible, and Eclipse with GCC ARM embedded tools. So, large number of applications are available. So, thank you everyone for your patience. I have hope you have enjoyed my lecture. Thank you all.